people. Now we're going to move on. We're going to go from linear stuff. We did linear systems, linear inequalities, all that stuff. We're going to be moving on to quadratic functions. Okay? All right. So with a quadratic function, like linear, would have just been like y equals 5x minus 2. Notice no exponent listed here because it would have been 1. It's something to the first power. Now we're going to move on to quadratic, which are going to have a second degree term, like it would look like y equals 5x squared minus 3x plus 5, something like this, where these can be anything except a can't be 0 because you need an x squared term, because a 0 would make that disappear. So we're doing quadratic functions, and they're in this form right here, right? Where I said the things in gray can be anything except for a can't be 0. All right, so let's start off by graphing a quadratic function to see what they look like. Now, before we were dealing with linear equations that looked like this, and sure enough, when you graph them, they'd look like a line. Let's see what a quadratic looks like. So we'll just start with this one. I'm going to choose some x and y values. I'm going to tell you how to choose your x and y values for particular quadratic functions in a little bit. Right? I'm just going to choose the values. Negative, I'll make it -2, -1, 0, 1, and 2. All right. So when I evaluate these, we're going to find our y values. We'll see what it looks like. So when you take -2, you take -2 in here and you square -2. When you square -2, it's -2 times -2, which gives you 4, right? So it's going to be 4 there. When we plug in -1 here, -1 squared, -1 times -1, when you square it, gives you 1. You plug in a 0 here, 0 squared is 0. 1 squared is 1, 2 squared is 4. So remember, I just told you, when you plugged in -2, you squared it, became +4. When you plugged in -1, squared it, became 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Let's graph this. So it's -2, 4. That's right here. It's to the left 2, up 4, right? -1, 1. To the left 1, up 1, right? Right here, 0, 0, 1, 1, 2, 4. And look, it's not linear. And it's not two rays, right? Or two lines. It's curved. See that? You see, as you're going to the right, it goes to the right 1, up 1. Then it goes to the right 1, up 4. Are you thinking doesn't have a constant slope, like goes up 1 to the right 1, now it goes to up 4 to the right 1, and then it's going to go up even more, right? 5 to the right 1. All right, so taking a look at this, right? This is a quadratic function. It's what we call has a parabolic shape. It's a parabola. In this case, we have what's called our vertex. Our vertex is going to be vertex at 0, 0. A vertex is going to be a relative maximum or minimum. This is a minimum, right? It's going to have an axis of symmetry, right? This thing's symmetric. You notice it's symmetric. Has an axis of symmetry at x equals 0, right? X equals 0 is the vertical dotted line, right? Remember that? So it has an axis of symmetry at x equals 0. All right, this all making sense? Then we're going to do the next one really quick. And all quadratic functions, when you graph them, are going to be parabolic. And then we got this one. So you can get rid of this now. There we go. When I plug it in, now when I plug this in, here's what happens, right? You have y equals negative, and then you plug it in there, you square it, and then you got to do the negative on the outside. So taking a look at this, you take negative 2, square it's 4, becomes negative 4. You take negative 1, plug it in, negative 1, you square it, becomes 1, negative 1. 0, you square it, 0, negative 0, which is just 0. 1, 1, you square it, 1, then negative 1, 2, you square it, 4, and then becomes negative 4. So you notice we get negative 4 here. That's what I said. You square it, and then you have to do the negative in front. When you square it becomes positive, then you have to do the negative in front. Negative 1 here, 0, negative 1, negative 4. All right, when we graph this now, you have negative 2, negative 4. You have negative 1. We have negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4. All right, so you'll notice it looks similar, but this one's opening down as opposed to up. So on this one, you have a vertex at 0, 0. In this case, it's a maximum, right? And it's technically, I should say, it's a maximum of 0 at x equals 0, but whatever. All right, and then you have a axis of symmetry here. See, the axis of symmetry is at x equals 0. But I mean, what we're really concerned with is these are the graphs of the functions, right? Parabolic. Okay. All right, so I'll do one more part. All right, so now we're going to do graphing a quadratic function. This thing gets a little bit more difficult here. Now remember how I showed you the axis of symmetry? It makes it easier to graph this if you know your axis of symmetry. And we have this thing right here. When we're graphing a quadratic function, right, we already said this thing, the first one opens up because it's positive in front. The other one opens down because it's negative in front. That's always going to hold. All right, now the x-coordinate of the vertex comes from this, from negative b over 2a, and then the axis of symmetry is on the vertex. All right, so take a look here. See how we have the axis of symmetry where it's symmetric with respect to? Right here. And then you see how the vertex is on the axis of symmetry? That's going to help us. Let's show you how to graph this. All right. To make this easier to graph, the first thing we want to do is to find our axis of symmetry. All right. Once we know our axis of symmetry, we know it's going to be symmetric with respect to that. So where is the axis of symmetry? Here's how we find it. Okay. It's going to be this, and it comes from the quadratic formula, which we haven't covered yet. It comes from negative b over 2a. That's going to be our axis of symmetry. That's going to be where that vertical line is going to be on the x-axis. This is of the form ax squared plus bx plus c. So in this case, it's going to be negative b. B is negative 8, right? Over 2a, 2a, and a is 2. So you get negative 8. So that's 8 over 2 times 2 is 4. So you get 2. So the axis of symmetry is at 2. Okay? So it's going to be right here. It's going to be symmetric with respect to that. And then we're going to have 2 in the middle. 2 is going to be our vertex. All right? And you'll note when I plug in 2 here, now we're going to find our y value for 2 to find our vertex. So we're going to plug in 2 now. So I'm plugging in 2 here, right? And we're going to find our y with the 2. So we're going to get 2 squared is 4 times 2 is 8, minus 16 plus 6. 8 minus 16 is negative 8 plus 6 is going to give you negative 2. So we get a negative 2. So this thing's going to start at 2, negative 2. Now you can figure out whether it's going to open up or whether it's going to open down. Now you'll notice that the lead term over here, a, is positive, so this will open up. Here's what I'm going to do. For these, all you have to do is choose one side. So see the x value? The x axis of symmetry and the x value of the vertex? We're going to choose two values on one side and two values on the other side. So I'm going to choose 1 and 0. It's two values on the left-hand side. We're going to choose 3 and 4. And you really, 1 and 0 are going to get the same y's as 3 and 4. You'll see. It's going to make it easier. All right, so here's what I'm going to do. Now I'm going to go ahead and I'm going to find the other y values. So we're going to plug in, why don't we plug in 1, 2 times 1 minus 8 times 1 plus 6. So I'm plugging in the 1 right there, right? 1 squared is 1 times 2 is 2 minus 8 times 1 is 8 plus 6. So you get 2 minus 8 is negative 6 plus 6 is going to be 0. That should have been a plus 6, all right? So we found that now. And now I'm just going to plug in 0, 2 times 0 squared. So I'm plugging in the 0 now. Minus 8 times 0 plus 6. So the first two terms go away, don't they? So you just get 6. So when I plug in 0, I get 6. And guess what? Once you do that, it's always going to be the same on the other side. All right? If you start with the axis of symmetry. So I only had to find these, and then these are going to be the same, and those are going to be the same. Let me just verify and show you that really quick. See, when I plug in 3 now, 2 times 3 squared minus 8 times 3 plus 6. 3 squared is 9, times 2 is 18, minus 24 plus 6. So 18 minus 24 is negative 6 plus 6 is 0. See how that works? See why that works? Then when I plug in 6, I have 2 times 6 squared minus 8 times 6 plus 6. 6 squared is 36 times 2 is 64 minus 48 plus 6. 64 minus 48 is going to be, so you got, oh, I'm sorry, I misspoke. It's not, you're not plugging 6 in, you're going to plug in, I'm sorry. Wish I could cut that out really fast, but you're going to plug in 4. We're plugging in 4, not 6. I messed up there. All right, so you got 4 squared is 16 times 2 is 32 minus 32 is 0 plus 6 is 6. See how we get that? See how that works? So yeah, sorry about that. I wasn't plugging in 6. I was plugging in 4. Yep, now we can go ahead and graph it. So we got 2, negative 2. We got 1, 0, 0, 6. And then it's going to be the same on the other side. 3, 0, 4, 6. There we go. And it's pointing up. See how it's opening up? So this thing has a vertex at 2, negative 2. It's a minimum because it's opening up, because it has a, we'll say it has a minimum of negative 2 at x equals 2. All right, and then its axis of symmetry at x equals 2. That's the vertical line. All right, okay.